Hey everybody, we're gonna go over the evens on this review, all right, that you had for homework. All right. Hopefully you are starting to feel a little bit more confident about this. Some of them obviously a little easier than others. All right. So starting with number two. All right, we have a situation here where we have the degree on top is one, the degree on the bottom is one. So we have the degrees are the same, which means we will have a horizontal asymptote for this problem. We take the leading coefficient, which is -2 over 1, which is -2. So I have a horizontal asymptote of y equals -2. All right, I have a vertical asymptote, set the bottom equals 0 at x equals 2. X-intercept, set the top equal to 0, which gives me 5 equals 2x, which means x equals 5 halves. So 5 halves, comma, 0. Make sure you write it as a point. Y-intercept, plug in 0 there, and I get 5 over -2. So that is 0, comma, -5 halves. All right. So now that we have all of that information, now we just graph. All right. So let me change the color here. All right. So we have a vertical asymptote at x equals 2. We have a horizontal asymptote at y equals -2. Okay. Now, our x-intercept is 5 halves. 5 halves is 2.5, correct? So it's going to be right there, 2.5, comma 0. Y-intercept at 0, -2.5. So it's -1, -2 right here. So when we have a vertical and a horizontal asymptote, they're split up into 1, 2, 3, 4 quadrants. Remember, you have one curve on the right side, one curve on the left side of a vertical asymptote. We already have points in 2 different ones, so we are good. Looks something like that. And remember, the curve always should be going towards the asymptotes. Looks like that. All right. Symmetry-wise, this is not going to be symmetric. You can't flip it over the y-axis, and you can't rotate it 180 degrees to be the same thing. So symmetry is none. All right, there's number 2. All right, number 4. All right, we have a situation where we have the degree is 1 on the top, bottom, nothing on the top, which means bigger on the bottom automatically means y equals 0. All right, our favorite one, the degree is larger on the bottom. Vertical asymptotes at the bottom equals 0, x equals 1. X-intercept, there's no x up there, so there is none. All right. In this one, for the y-intercept, you plug in 0 and you get what? -3 over -1. So what is that? 3. So 0, comma 3. All right. And now we are going to graph our asymptote. So y equals 0 and x equals 1. All right. Now there is no x-intercept, but there was a y-intercept at 0, comma 3. All right. So let's make sure we put that in, and that's right here. All right. So that tells us that we're going to have a curve going like that. I need a curve on the right and left. Top or bottom, I don't know. So I'm going to plug in something that's to the right of this asymptote. Since the asymptote's at 1, let's plug in like 2. So we get -3 over 2 minus 1 is 1, which is -3. So at 2, it'd be -3, which is down here, which means I'm in that quadrant. You don't need to actually graph the point. I'm okay with just putting roughly where it should be. All right. Once again, whenever you have a vertical asymptote here, it's not at x equals 0, you're not going to be able to flip over and be the same picture. All right. And if I rotate this, it's not going to be the same picture either. So this is none. All right. All right. So now number 6. Once again, 2 up top, 2 in the bottom. The degree is the same, which means we have a horizontal asymptote, and it's at y equals whatever the leading coefficients are. 2 over 1 is 2. Bottom, set the bottom equal to 0. X squared minus 16 is x minus 4, x plus 4. So we have 2 vertical asymptotes, x equals plus or minus 4. X-intercept, set the top equal to 0. 0, comma 0, 2x squared. So 0 is the only thing. Y-intercept, plug in 0, I get 0 over negative 16, which is also 0. So it's 0, comma 0 for both of them. All right, so this is where we have our situation with 2 vertical asymptotes and 1 horizontal asymptote. 1, 2, negative 3, negative 4. All right. Now, before I even graph this, all right, just want to over here show you. Remember, there was 4 situations that can happen. 1, it's not really. It's 1, 2. When we have 2 vertical asymptotes and 1 horizontal. Okay, so this is what normally will happen, all right? If you have a parabola going up, that means these are on the bottom. If you have a parabola going down, these are on the top. You could have an S-curve that looks like this, where this goes to the top, which means you're on the bottom. If this goes to the bottom, this is on the top. The S-curve could also go this way, all right? And then that means this is on top, that's on the bottom, all right? Those are the 4 possibilities that you can have when you have this situation. Now, if the vertical asymptote, the horizontal is up here, you're probably not going to have an S-curve because this is too far away to pass at the origin, okay? So when I see this right here, I'd be willing to bet a lot of money that this is not going to cross up here, all right? It only could cross around the origin, okay? So it doesn't cross unless you have it's at y equals 0 and it's right around the origin it crosses. So this is not going to go up there. But just to make sure, if I plugged in 1, I would get 2 over negative 15. That is a negative number, which means I have to go down. All right, you only have 2 options. You have to go towards the asymptote. If I plugged in negative 2, since these are both squared, the same thing's going to happen. All right, this is also going down, and that's what we would expect to happen. Since this is going down, this is just like this picture here. It's going down. It's not going to be on the bottom here. It's going to be on the top. And then this one's going to be on the top because that's going down. And there's your graph. Right? So if you can kind of just remember these things here, it's going to help. Or if you just figure out what's happening in the middle, you can figure out what's happening with the other ones. But if you don't know, you could always plug in points. If I plugged in 5, I would figure out that the point was up here. And I know the curve's here. If I plugged in negative 5, it would be here. But you don't necessarily have to do that. Now, for this one, for symmetry, see how both asymptotes are on the same side here? If I flipped it over the y-axis, what would happen? I get the exact same picture. So when that happens, that is even. All right, and there's number 6. All right, so now on to number 8. Let me just zoom this in a little bit real quick. All right, that's better. All right, so now number 8. All right, so what do we have here? We have a degree of 2 on the top, degree of 1 on the bottom. So we have a situation where it's bigger on the top. So it's not going to be a horizontal asymptote. It's either a slant or a hole. All right, so let's just see if I can factor anything out of here. I can take out an x, which makes this 3x minus 2, but nothing cancels out here, so it's not going to be a hole. We're going to have a slant asymptote. All right, vertical asymptote is x equals 1. To figure out the slant, we are going to do synthetic division. 1, because that's what makes that equal to 0. We put a 3, negative 2, and a 0. Remember, we don't care about the remainder. We don't care about whatever comes here. Bring down the 3, multiply by 3, you get a 1. So it's y equals 3x plus 1. All right, that is our slant asymptote. X-intercept, set the top equal to 0. Since we've already factored it, makes this easy. It's 0, comma 0. and 3x minus 2, that is 2/3. So it's 2/3, comma, 0. Y-intercept, if I plug in 0, I get 0 over 1, which is 0. But we'll also notice, since one of the x-intercepts was 0, 0, the y-intercept will be 0, 0. All right, graphing. Vertical asymptote. All right, now slant. Remember, slant asymptote. This is the y-intercept. So it goes here, then it goes up 3. 1, 2, 3. To the right one, goes down 3. 1, 2, 3. To the left one. All right, so it's not the most perfect, obviously, thing in the world, but it looks something like that. Just extend it. All right, so when I draw my points in here, all right, remember, if a curve is here, the other one is in here. If the curve is on that one, the curve is there. You are still one on the right of the vertical, one on the left. The other one always goes opposite. The vertical angles, if you think of geometry, what we have for vertical angles, that's where the other curve will end up. All right, so what points do we have? We have 0, 0, which is right there. And we have 2/3, comma, 0, which is also there. So it means we have a curve that goes like, and then comes back down. So since the curve is here, I don't have any other points. It has to be this one. It's not this one. It's this one. And you can just draw the curve. You don't have to find a point there. All right. This does not have any symmetry. All right. And there's number 8. All right. So now with number 10. All right. Our last one, the ones we actually have to graph. And we look at the degree, and we got 1 and 1, which means this is the same, which means we're going to do -2, because we're going to take the leading coefficients, -2 over 1. So we have a horizontal asymptote at y equals -2. We have a vertical asymptote at x equals -2. We set this equal to 0, and that is 2. So I get a x-intercept at 2, comma, 0. Y-intercept, I plug a 0 in here, a 0 in there. It's 4 over 2, which is 2. A lot of 2's in this problem. All right, we then do my vertical, 1, 2, and my horizontal. So we just have one vertical asymptote, one horizontal. So curve has to either be in this one, or this one, and that one. All right. Points we have. 2. Well, let me go back to my pink for a second. All right. So we have a point at 2, 0 and 0, 2, which means they're on the same quadrant. So it's got to hit both and kind of look like that. Other ones either here or here. How do I get that? You plug in a number. Plug in -3. Why -3? It's to the left of -2. Could you plug -4 and -5 and -6? Yes. I'm going to plug in I'm going to plug in -3. So when I plug in -3, -2 times -3 is 6. 6 plus 4 is 10. -3 plus 2 is -1, which means I get a -10, which is down here. And there's my graph. All right. Now, for the ones down here, you do not need to graph it. It says it right here. You just need to figure out the asymptotes. All right. So you're just going to go through and follow your rules for each of those. Now, if we look at, for number 12, we look at the degree. The degree is larger where? The degree is larger on the bottom, which means we have a horizontal asymptote at y equals 0. Vertical asymptote. If I set this equal to 0, I would get x squared equals -3. I would get a square root of a -3, which is an I, imaginary. So there is no vertical asymptotes. X-intercept, you set the top equal to 0, which is -1, comma, 0. Make sure you raise a point. Y-intercept, 0 here, 0 here. You get a 1/3, so it's 0, comma, 1/3. Right? That's all you have to do for those problems is follow your steps. No graphing needed. All right. All right. So now we are going to do 14 and 16. Almost did 15 there. We're going to do 14 and 16. So these are solving inequalities. We're doing these by hand. So when we do these by hand, all right, you have to find the critical values. The critical values are, oh, didn't realize that was a 2. My bad. First, I thought that was a 0. So first what we're going to do is we have to bring over the 2. So it's x plus 2 over x minus 3 minus 2 is less than or equal to 0. So we need to make this into one fraction. Then we can find the critical values. So that's going to be x plus 2 over x minus 3 minus 2 times x minus 3 over x minus 3, because x minus 3 is our common denominator. All right. That's going to give us negative 2x plus 6 when I distribute it. So x minus 2x is negative x. 2 plus 6 is 8. So I get negative x plus 8 over x minus 3 is less than or equal to 0. All right. Now you find your critical values. So wherever the top is equal to 0, in this case, it's going to be 8. All right. And whatever the bottom is equal to 0, which is 3. All right. So we are going to make a number line, and we're going to put those numbers on it. 3 and 8. All right. Now we are going to plug numbers in that are less than 3, between 3 and 8, and greater than 8. And we're going to put them right here, and we're going to see whether they're positive or negative. So if I plug in 0, pick 0 because it's easy to work with, I get 8 over negative, you get 8 over negative 3, which is a negative number. All right, I get a negative number. If I plug in 5, I get negative 5 plus 8, which is 3, which is positive. And then I get 5 minus 3, which is also positive. So that is a positive number. All right. When I plug in 10, I get a negative over a negative. Let me get. If I plug in 10, it's negative 10 plus 8, which is a negative. And then I go 10 minus 3, which is a positive. Negative or positive is a negative. Okay. So now, since we are looking at where it's less than or equal to 0, all right, I'm looking wherever I have the negatives. All right, so I have answers negative infinity to 3, union 8 to infinity. Now, the infinities always get your parentheses. Since this is a less than or equal to sign, something might get a bracket, all right? What's going to get a bracket is whatever makes it equal to 0, not the bottom. The 3 never, the asymptote never gets a bracket. So that's a parentheses. The 8 gets a bracket. And there's your answer. Negative infinity to negative 3, union 8 to infinity. All right. So now we're going to do 16. All right. This is already set equal to 0, so we don't have to worry about that. But we do have to combine this into one fraction. All right. So the common denominator is just going to be multiplying both the same. So it's going to be x minus 3 times x plus 1. All right. And x minus 3 times x plus 1. All right. All right, so we have 2 times, well, we had x minus 3, so we had to multiply that by x plus 1. 1 times x minus 3. So just so we don't have to rewrite all this, I'm just going to multiply them here. So it's 2x plus 2. This is negative x plus 3, because I just made this a negative 1. Negative 1 times x, negative x. Negative 1 times negative 3 is positive 3. So when I do 2x minus x, I get x. When I do 2 plus 3, I get 5. So I get x plus 5 over x minus 3 times x plus 1 less than equal to 0. All right, so now that we have x plus 5 over x minus 3 times x plus 1, we're going to find the critical values. So you set the top equal to 0, so that's negative 5. set the bottom equals 0, 3, and negative 1. And we're going to make our number line. Make sure you put it in the proper order. Negative 5, negative 1, and 3. All right, so now we are going to plug in numbers. All right, so when I plug in, let's say negative 6 plus 5, that is a negative. Negative 6 minus 3 is a negative. Negative 6 plus 1 is a negative, but negative times a negative is a positive. So I get negative over positive, which is a negative. When I do negative 2, negative 2 plus 5, that's still a negative. Negative 2 minus 3 is still a negative 2 minus 3 is still a negative. Negative 2 plus 1 is still a negative. So I get negative times a negative, which is a positive. So I get a positive on the bottom. However, I made a mistake here. But I plug in negative. Negative 2 plus 5 is a positive. Sorry, so positive over positive, you get a positive. If I plug in 0, 0 is a positive up there. That's a negative times a positive, which is a negative. Positive or negative is a negative. Plug in like 5. 5 plus 5 is positive 10. 5 minus 3 is positive, positive, positive or positive, positive. We are looking for where it is less than 0. So we're looking for all the negatives. So here and here. All right. So we have as an answer negative infinity to negative 5 union, what is that? Negative 1 to 3. And since it's less than, there's no equal to there, everything, it's easy, everything gets a parentheses. All right, and there you go. All right. All right, so the last thing to finish up will be the true and false. All right, 18, the line x equals 1 is the vertical asymptote of the function f of x equals x plus 4. This is, I hope, an easy one, all right? The vertical asymptote comes from the bottom, which is negative 4, so this is false. And if it said state y, you could just write that should be x equals negative 4. That's what the vertical asymptote should be. All right. Then the last one, 20, 2/7 is an x-intercept of the graph of the function 2 minus 7x over x plus 3. Well, to find x-intercept, you set the top equal to 0. So 2 minus 7x, set that equal to 0. I get 2 equals 7x, divide by 7, and I get 2/7, and that is a true answer. All right. So we've now gone over this review entirety with the odds and the evens. We'll have one more day of review before we will have your quiz. All right. Hope everyone's doing well, and I'll talk to you guys soon. All right.